Hello, my name's Owen. I'm a tutor here at Breakthrough Maths, and today we're going to be doing a crash course on four areas of algebra: quadratic equations, long division, algebraic fractions, simultaneous equations. Let's get straight to it. First thing I'm going to do, quadratic equations. This is arguably one of the main areas of algebra for your Leaving Cert. You are basically guaranteed to see a quadratic equation somewhere. You're going to be solving it, you're going to be getting the roots, you're going to be getting its maximum, whatever. You're going to see a quadratic equation. What even is a quadratic equation? Well, it's an equation that looks like this. Ax squared plus bx plus c. A, B, and C can be any number you like, but this is how you can recognize a quadratic equation. It looks like this. I'm going to give you an example. So, say I have x squared plus 5x plus 4. First step of solving this equal to 0. That would be the question you get. It would be solve this quadratic is equal to 0. First step, there's an invisible 1 in front of this x squared, I hope you know. So we're going to write out the factors of the term in front of the x squared and the last term. So the factors of 1 are just 1 times 1. And the factors of 4, they could be 1 times 4, or 1 times 4 or 2 times 2. Now, step 2, we need to find a combination that will add to 5x. So we're going to multiply these across. 1 times 1 is just 1x, and then 1 times 4 is going to be 4x. And if we have a plus 1 and a plus 4, we're going to get the 5x we need. So we don't even need to consider these two. So we have it. We have now two brackets. That's step 3. Write the brackets. We have a 1x here, and we're going to have another 1x here. And then we're going to put a plus 1 in this bracket and a plus 4 in this bracket. Now, last step. For this to equal 0, okay? Say over here, for example, if I have 4 times x is equal to 0, what does x need to be for this equation to be true? 4 times something is 0. Well, then the something just has to be 0. The x has to be 0 for that to hold. So now, if we look at this, these brackets are multiplying and they're equal to 0, then either this bracket has to be 0, this bracket has to be 0, or both of the brackets have to be 0. So let's do each case. Let's say this bracket here is equal to 0. Well, if x plus 1 is equal to 0, then x must be minus 1. And here, if x plus 4 is equal to 0, then x must equal minus 4. And there we go. That is the solution to this quadratic, okay? Was it 3 or 4 steps? Step 1, write out the factors of the term in front of the x and at the end of the equation. Step 2, multiply across to get something that you will, when you add these two, you're going to get what's in the middle with just the x. Then, third step, write the brackets equal to 0. Fourth step, each bracket equal to 0, you're going to get the x. I'll give you another one. I want you to try this before I solve it. Ideally one with a 2x squared, because these ones are kind of tricky. I'm going to try it. So if I have 2x squared plus 11x plus 5 is equal to 0. Solve this, okay? Take a second, pause the video, try it on your own. I'm going to do it now. So, first step again. Write out the factors of this. It's going to be 2 and 1, and then the factors of 5 are going to be just 1 and 5. Simple. Now, we need to find a combination that will add to 11x. So let's try this. 2 times 1 is 2, and 1 times 5 is 5. 2 plus 5 is only going to give us 7. Or, 2 minus 5 is going to give us 3 or whatever. We're never going to be able to get a combination that will add to 11 here. So that won't work. Well, let's try this. The 2 times the 5 is going to be a 10. And then the 1 times 1 is going to be a 1. And if we have both of these as positive, 10 plus 1 is 11. And then if we multiply these, we're going to get the 5 we need. So perfect. Let's write the brackets. Now, I'm going to put the 2x into this bracket and the 1x into this bracket. Now, this is the key step students mess up. The 2 has to multiply with the 5, okay? So the 5 can't go in the same bracket as the 2, because if it did, it would never be in a scenario where the 2x and the 5 can multiply. So if I put the 5 over here, when I expand these brackets, we're going to be able to multiply the 2x and the 1, and the 5. Same here with the 1 and the 1, the 1x and the 1. They have to be in opposite brackets so that we can multiply them. I hope that makes sense. So then, yeah, we have this final step then, each bracket equal to 0. So 2x plus 1 is equal to 0. So then 2x must equal minus 1. So x must equal minus 1 over 2. Here we have x plus 5 is equal to 0. So x must equal minus 5. Boom. And there's your solution. And that's all there is to quadratic equations. Worst case, if this doesn't work, if you can't find a combination that will give you this number in the middle, the backup plan is our good pal minus b formula. X is equal to minus b plus or minus square root of b squared minus 4ac all divided by 2a. Where a, b, and c are just these numbers here. A will be the number at the front, b will be the number in front of the x, and then the c will just be the other number in the equation. So worst case, you can solve it this way. Throw all these numbers into the minus b formula. You're going to get two numbers, two x values, and work with them. And that's all there is to quadratic equations. All right, number 2, long division. This isn't as guaranteed to come up as quadratic equations in your Leaving Cert, but it's still really good to get to know these. So we want to divide x cubed minus x squared minus 10x minus 8 by x plus 1. Well, okay, let's start. First thing we have to do, we divide the term in the front by whatever is at the front here. So in this case, it's just going to be a 1x. So we're going to divide 1x cubed by 1x. So when we do that, we're going to get an x squared because x cubed divided by x is just x squared. Slap x squared up here. Second step, we're going to distribute the x squared down here and multiply each of these by x squared. So x times x squared is going to be x cubed. We're going to write that here. And then x squared times 1 is just going to be x squared. Boom. Draw the line, flip the sign. That's what I always say. Draw the line, flip the sign. Flipping or changing the sign, there's no real intuitive way I can explain why you do it. This is just a rule you have to remember. You have to change the sign before you move forward so that these two are going to cancel when you add them. And then we're going to have minus x squared minus x squared. That's going to be minus 2x squared. And then last step, bring down these fellas, put them down here. Don't forget about them. What do we do now? Same exact thing. Rinse and repeat. So minus 2x squared divided by x, that's going to be minus 2x. Again, we're going to multiply each of these two now by minus 2x. So minus 2x by x is minus 2x squared. And minus 2x times 1 is minus 2x. Boom. Draw the line, flip the sign. We're going to make this a plus, make this a plus. Minus 2x plus 2x, these are going to cancel. And then we're going to be left with minus 10x plus 2x, that's going to be minus 8x. Don't forget about this 8, bring him down. Perfect. One more time, rinse and repeat. Minus 8x divided by x is minus 8. And then we're going to multiply the minus 8 by the x and the 1. So we're going to have a minus 8x. And then minus 8 times 1 is minus 8. And this is now how you're right. Because when you draw the line and flip the sign, you're going to have a plus here and a plus here. And these are both going to cancel. So we're going to be left with the 0 down here. And that's how you know there's no remainder. So you've probably done it right if you got this. So now this is our answer. So we have that x cubed minus x squared minus 10x minus 8 divided by x plus 1 is equal to x squared minus 2x minus 8. And there we go. That's all there is to it. We can also write this as x cubed minus x squared minus 10x minus 8 is equal to x plus 1 times x squared minus 2x minus 8. These are the same thing. We just multiplied across by the x plus 1. But this is what you get. You divide each term by the term in the front. You then distribute that down to the other two terms, write them there, draw the line, flip the sign, add them, bring the other fellas down, rinse and repeat. I'm going to do another one. Well, you're going to do another one. And I'm going to do it as well. Why not? So, real quick, pause the video and try this. So it's x minus 3 going into x cubed minus 2x squared minus 23x plus 60. Sorry, that line is very squiggly. X cubed minus 2x squared minus 3x plus 60. Try that really quick. Pause the video. Give it a go. I'm going to do it now. So, in a bit of less detail than the last one, x cubed divided by x is going to be x squared. Distribute that. We're going to have an x cubed and then a minus 3x squared when we multiply these. Draw the line. Flip the sign. Boom, boom. We're going to have these x's cancel, the x cubes cancel rather. And then we have minus 2x squared plus 3x squared. We're going to be left with an x squared. And then bring these fellas down. Minus 23x, that's a terrible 3, plus 60. Rinse and repeat. X squared divided by x. That's just x. X times x, x squared. X times minus 3, minus 3x. Draw the line. Flip the sign. Minus here, plus here. So x squared minus x squared is going to cancel. 23x minus 23x plus 3x is going to be minus 20x. And then don't forget this guy, plus 60. Now, final step. Minus 20x divided by x, that's going to be minus 20 here. Minus 20 times x, minus 20x. Minus 20 times 3 is going to be 60. Draw the line, flip the sign, and... oh. Sorry, guys. When we draw the line and flip the sign, these are going to cancel, and these are going to cancel, and we're going to be left with 0 down here. So this thing here, I'll highlight it in green. Oh, well, that's black. You know what? We'll stick with that. That there is our answer. So x cubed minus 2x squared minus 23x plus 60 divided by x minus 3. We're going to get that quadratic at the top. And that's all there is to long division. That's all it is. Those steps, rinse and repeat, do it multiple times, and you're going to get it. And this is going to be a nice question if it comes up on your Leaving Cert. All right. Third thing, algebraic fractions. An example would be something like 1 over 4x minus 2 minus 3 over 3 minus 2x. Now, the idea here is we want to simplify this expression. How do we do that? We want it as one fraction. So what we always do is we multiply these across, the guys on the bottom. We multiply these across and we multiply them then together to get the denominator. That was a terrible way of explaining it. No, okay, scrap that. Start again. Algebraic fractions. They look something like this. And the idea now is we want to simplify this. And it's the same, like, if we have fractions, say I gave you 1 over 2 minus 1 over 4. We can't just minus the top and the bottom. We need the denominators to be the same. So this would have to be like 2 over 4 minus 1 over 4 is equal to 1 over 4. We need to do the same thing here. We need the denominators to be the same. So what we do is we multiply the denominators across like this, but then the denominator is going to become the product of these two. So I'll write that out. So we're going to have a 4x minus 2 times the minus 3 plus the 1 times 3 minus 2x, all divided by 4x minus 2 times 3 minus 2x. Now, this thing we have here is the exact same thing as the expression on the left. We've just moved everything into a single fraction, like we would have done up here. So now, let's simplify this. 3 times 4 is going to be 12x, minus 2 times 3 is going to be minus 6. We're going to have a plus 3 minus 2x from the other brackets, and then we're going to have 4x minus 2 down here, and 3 minus 2x down here. Now, you could expand this bottom bracket, but if we want to simplify the expression, we want to leave the brackets like this, typically. But sometimes they might want you to expand this bracket to have a quadratic. It really depends on the question. I'm going to leave it for this case. So right now I'm going to underline the similar terms. So we have the x's here and we have the other terms here. So 12x minus 2x, we're going to have a 10x. Minus 6 plus 3 is going to be a minus 3, all divided by 4x minus 2 times 3 minus 2x. And there we go. That is that fraction simplified. Except, of course, again, we could multiply out the bottom, the denominator, but it kind of depends on the question whether you actually have to do that or not. So yeah, I'm going to give you a question to try now. Give this a go. We have x plus 2 divided by 3 plus 2x minus 1 divided by 4. Pause the video and simplify this for me. I'm going to do it now, and I hope you've done it, or at least tried it. So again, what we're going to do, we're going to multiply the bottom numbers up here. Up, we call that. And then the denominator is going to be the product or the multiplication of these two guys. So we're going to have 3 times 2x minus 1 plus 4 times x plus 2, all divided by 3 times 4. Just like that. Okay, now let's expand out the brackets. 2 times 3 is 6x minus 3. It's a terrible 3. Minus 3. And then the 4 times x is going to be a 4x. And then the 4 times the 2 is going to be an 8. All divided by 3 times 4 is 12. Again, underline what's in common. A very good tip. Underline in a different color pen what is in common. So we have the 6x and the 4x. That's going to be a 10x. 8 minus 3, that's going to be a 5, all divided by 12. Boom. And that's it. We've simplified that fraction, and now it's this. And that's basically what you do every time. You multiply across, the denominator becomes a product, and then you just have to simplify the expression and get the final fraction. One more example. Now, this is slightly different. It is, we want to simplify 2x squared minus 7x minus 15 divided by x squared minus 25. Try to simplify that for me on your own. This is quite different to what I've just done, but give it a go, see if you can do it. I'm going to do it now on my own. The key here is noticing that we can factorize these. This one here would be a quadratic factorization. And this guy down here would be a difference of two squares factorization. So, how do you factorize a quadratic? Well, let's do it up here in purple. The factors of 2 are just 1 and 2. And the factors of 15 are 1 and 15, 3 and 5. Now we want a combination that will add to -7. I've already done quadratics with you. We can already see that this 1 and 15 isn't going to work. Let's rub him out. Now we want a combination that will add to -7. Well, I can see here if I do 2 times 5 is 10 and 1 times 3 is 3. If I do a 10 or a minus 10 plus 3, I'm going to get the -7 I need. And if I multiply these, I'm going to get the -15 I need. Perfect. So on the top of the fraction, I'm going to have a 2x here. I'm going to have the 1x here. And notice again, the 2 is multiplying with the 5. So I need to put them in separate brackets so they can multiply. So I'll put the -5 over here. I'll put the +3 over here. And if you're ever in doubt of whether you factorize something correctly, you can multiply it out in your head. So like 2x times x is 2x squared. 2x times -5 is -10. Then we have a +3x here, which is going to give us -7x. And +3 times -5 is going to give us -15, as we expected. Now, to factorize the bottom, we will have to use the difference of two squares. Difference of two squares is x squared minus y squared is equal to x minus y times x plus y. There is no real way you can work that out. This is something you just have to know. You have to be able to recognize this. It's useful if you can recognize square numbers. So like 1, 4, 9, 16, 25, 36, 49. If you can see that this is like 1 squared, 2 squared, 3 squared, 4 squared, whatever squared, it's really handy for solving difference of two squares problems. So in this case, we're going to have x squared minus, well, 25 is just 5 squared. So using keyword here, difference, the D here stands for difference. That's only if there's a minus sign here. That is crucial. And then you have the two squares. That's what the TS are. TS is two squares. Square 1 here and square 2 here. Same here. The x is squared and the 5 is squared. And we have the difference, so we can write. I should do it in blue, sorry. We should write x minus 5 times x plus 5. Boom. Throw these up here now. We factorize the bottom. We know now it's x minus 5 times x plus 5. Well, we can see here that because these are both multiplying, the top and the bottom, the 2x plus 3 is multiplying with the x minus 5, and the x minus 5 is multiplying with the x plus 5. These x minus 5s are going to cancel with each other. And then what we're left with is 2x plus 3 over x plus 5. And that'll be our final answer. And that's all there is to algebraic fractions. It's either we're simplifying by minusing one off the other, multiplying them, dividing them, adding them, subtracting them. We could just have a fraction like this and we have to use our rules of factorization to find out how to simplify it. But that's all there is to it. Once you know the rules of factorization and you know the basic idea of how to add and subtract fractions, you should be golden with this. Simultaneous equations, okay? Three types of simultaneous equations. We could have two-dimensional, which would just be x and y. We could have three-dimensional, which is what we have here with x, y, and z. And then the third one we could have is non-linear, which is when we'd have like an x multiplying with a z, or with a y, or an x multiplying with a z. If they're ever multiplying like that in a simultaneous equation, it's called non-linear. Right now, I'm going to focus on this middle one, the three-dimensional one, because we already do the two-dimensional one as a byproduct of the three-dimensional one. The non-linear one, I'm not going to have time to cover today. I'm going to cover this on my own. I'm going to give you one to do on your own, and hopefully you understand it. So, this is how you solve this. We want to get rid of one of these terms, the x, y, and the z. We can't solve this with all three of them. First things first, we have to get rid of one of them. I'm going to get rid of the z's first. So I'm going to take these two equations. I'm going to solve these over here and try to cancel the z's. And then these two I'm going to do down here. So let's do this. I'm going to write these top two equations again up here. So I have 4x minus 2y plus 3z is equal to minus 2. And 2x plus 2y minus 2z is equal to 12. Actually, now that I see this, I'm actually going to change my mind. I'm going to cancel the y's instead. Because if you see here, when we add these two equations, we have the minus 2y and the plus 2y are going to cancel automatically. So we don't have to do any work. See, I was going to multiply this top equation by 2 and this bottom equation by 3 to get a 6z here and a minus 6z here. It's easier because I just have the y's here already cancelled. So let's add these up. 4x plus 6x, or 4x plus 2x is 6x. The y's are going to cancel, and then the 3z minus 2z is just going to leave us with a plus z. And then minus 2 plus 12 is going to be 10. Boom. Box this equation off. Don't forget about this equation. This is number 1. This is equation 1. We'll come back to him. Now, these equations. We have 2x plus 2y minus 2z is equal to 12, and 3x plus 4y minus z is equal to 16. Now, because we got rid of the y's in this equation, or in this equation, we need to get rid of the y's in this equation as well. So what I'm going to do is I'm going to multiply this top equation, this whole thing, I'm going to multiply it by minus 2. Why do I do that? Because we have a plus 2y here and a plus 4y here. And I want it so that when I add these equations, the y vanishes. So multiplying this equation by minus 2, I'm going to get a minus 4y here, and then that will cancel with the plus 4y, and I'm going to get 0 there for the y's. Negative 4y plus 4z is equal to minus 24, because I multiplied that whole top line by minus 2. And then the bottom line we can just keep the same. 3x plus 4y minus z is equal to 16. Boom. Add these up. Minus 4 plus 4, they cancel. Minus 4 plus 3 is going to give us a negative x. Plus 4z minus z is going to give us a plus 3z. And that's equal to negative 24 plus 16, which is going to give us a negative 8. Is that right? Yeah. So yeah, that'll give us a negative x. That will give us a 3z. Okay, perfect. I hope that's right. Box this off. Number 2. Now, next step. We have our two equations. See, earlier I was talking about a two-dimensional simultaneous equation. That'll look something like this. 6x plus z is equal to 10. And then we're going to have this equation, minus x plus 3z is equal to 8, I think, minus 8. So yeah, now we've transformed our three-dimensional system of equations to a two-dimensional system of equations. Now we need to solve this. How are we going to solve this? Exact same method as before. We want to cancel either the z or the x's. Look, I'm going to multiply this bottom equation by 6. Because when I do that, I'm going to have a 6x up here and a minus 6x down here, and they're going to cancel. So 6x plus z is equal to 10, and then we're going to have a minus 6x plus 18z is equal to 6 times 8 is negative 48. Well, minus 8. So yeah, draw a line. These two are going to cancel. We're going to have a 19z is equal to negative 38. So that means z is going to equal, got to make sure on the calculator, 38 divided by 19 is in fact minus 2. Boom. That's our z value. So now what do we do? Actually, I'm gonna double underline it. Now we fill this z value into the two-dimensional system to get the x value back. Because we can't fill into our original equations because there's the y as well, and we don't know what the y is just yet. So I'll fill it into this one on the top. So 6x plus z we know is 10. Well, z is minus 2, so 6x minus 2 is equal to 10. That means that 6x is equal to 12. And dividing by 6, we get that x is equal to 2. There we go. Now we know x and z. Last thing, we fill into the original equation. Any one of the three equations. I'll fill it into the second one just for no reason. So we have 2x plus 2y minus 2z is equal to 12. Well, x is 2. 2 times 2. Y we don't know yet. And then z is minus 2. So that's going to be minus 2 times minus 2. Sorry, the z's look like 2's. This is actually a 2. And that's going to equal 12. 2 times 2 is 4. Minus 2 times minus 2 is also 4. So we're going to get 2y plus 8 is equal to 12. That means 2y is equal to 4. That means y is equal to 2. And there we go. We've solved the system of equations. We have x is 2, y is 2, and z is minus 2. And that is the solution to this equation. If we fill those x, y, and z values into this, we should get either minus 2, 12, or 16, depending which one we fill into. I'm going to give you a system to solve on your own, a three-dimensional system. If I have x plus 2y plus 3z is equal to 10, I will have 3x plus y plus 2z is equal to 13. And then I will have 2x plus 3y plus z is equal to 13. Now, go ahead, try that on your own. I'm not going to have time to do that for you. This is just a crash course. This is kind of a taster of how we teach here at Breakthrough Maths. Hopefully, this has improved your understanding on some of the basic stuff in algebra. I would highly recommend you get good at these because this is going to help you perform better in your Leaving Cert. These are kind of fundamental parts of algebra that if you get really good at, you're going to be well set for your Leaving Cert. Thanks for watching. Hope you enjoyed, and I hope to see you again in the future.